Okay, welcome to the Project 8 hint video. Multiplication tables. Some of you may not know actually how those work, and it's probably because you're too young. I'll explain it to you as we go through, but may be a little odd, those of you who came up with computers. I have two files attached to this project for your use. studentmultiplicationtables.cpp. As you know, that's a source file. So I've given you some code, and in this code I have comments. The comments refer back to certain steps in the specifications, which is your PDF file. All right. So I have those, and I also have Visual Studio opened with the code from that CPP file. So you'll start a new empty project, add a new CPP file, and then copy paste out of it the one I gave you. Okay. Let's see. There we go. Oh, where are you? Here you are. Okay, so here's the PDF. Note that I have a hint here. It's really something you should look into. Read this document meticulously so that you understand what is required before you begin the logical design. Not hard to understand, but there's a reason why I say that. This is not difficult, but there's a lot of code in here that you need to think about before you start, sort of flailing away on your keyboard. So, based upon user input, this program generates dynamic multiplication tables. It uses a series of do loops and for loops to accomplish this task. This is already in your code. It gets you going and gives you your variables and declares them and initializes them. It says place all of your logic inside a do loop, which will continue executing until the user is ready to quit. All right, let's look at that. Now that's a Sentinel type post-test do while loop, right? So here's, step one. I've already given you that, but you need to read that. Here's your outermost do while loop, step two. So let's go down to the bottom of this and find the while associated with it. And here it is. Notice the two upper. Some of you have been trying to do this, and you've actually done a pretty good job of it, but some of you are not addressing it, and I haven't said anything because it's a minor point right now. We have more important things to look at. But, if you just have while quit flag equal uppercase character Y, and they type a lowercase y, well, obviously that'll be false because a lowercase y has a different binary value than uppercase. Or if you think of in the old ASCII tables, if you go and look at an uppercase A, it has a decimal value of 62, let's say. I'm not quite sure, but and then a lowercase a is up in the 90s. Well, if you compare 62 to 98, excuse me, they're not going to be equal. And so how do you handle that? Well, you can do it with a bunch of ifs and loops and all that, but the easiest way to do it is to use two upper. Now, you can use two lower as well. Let me explain to you what these do. Two upper takes whatever's in here, which is your quit flag, and temporarily casts it to an uppercase. Now, it doesn't really change the value of it. It just temporarily does for comparison operation. So it takes this, and if it's already uppercase, it doesn't do anything. But if it's lowercase, it uppercases it, and compare it not equal to this. All right. By using this, you can pretty much guarantee, just for one character anyway, that you're going to have what you need, and the user doesn't have to worry about it, and you don't either. So this is the bottom of your while loop. I have a two upper right here, and I'm comparing it, remember, equal to a character. This only works on a single character, by the way. There are other ways to do multiple characters. So if that's true, we go back up here. If it's the first time we've started in here, it's a post-test while loop, so it doesn't do anything here. It just falls in here. Now you're going to need to use the system object, step 3, to clear the screen every time, even at the beginning, even though there's nothing there, just do it anyway. Every time it comes through, it's going to clear the screen. It's going to reprint the title, which I've already done for you. All right. You can take a look at it and see what I'm doing, but that's basically it. This will validate, step 4 here, will validate a starting number. You must next modify the code to validate the ending number. So I've done the beginning number for you, okay, and I've got some comments here. And I'm using an error flag to tell me if they've, given me what I need or not. If the error flag is true, this is a way that you can say a little typing, but you could put error flag equal true, but it's going to look at this and see whether it's true or false. You don't have to compare it. If it's true, it goes in here. All right, so if they haven't given you what you need, you'll find out here, and then it's going to kick back in until they do give you what you need. All right. and it'll clear the screen and reprint. So that much is pretty straightforward, and I've given you that. Now it says here, enter the ending number. Here's the second series of couts and cins. All right, it says now validate the ending number. This is your job. Now I've done it for the start number up here, so obviously you can copy and paste some of this and have another do while loop that tests for the ending number. So it says similar to above, but a little bit different because you're comparing for something different. You're testing for something different. That's step 5 in the PDF. So you go back and look at that. Now I'm tabbing over and building the column header. This is step 6. I've already done that for you. I'm using a tab. This is called an escape character because when it sees that backslash, notice it's single quote, so that is considered as a single character. When the compiler sees a backslash, it says to escape, hence the name escape character, the normal use of this character and make it something else. In this case, it's a tab. You can have new lines, I think, which is an N and all that. There are easier ways to do it in other languages, but we're here and this is what we must do. Here's a for loop. It builds a column header for you. Already done that. Step 7, build your nested for loops. That should be in quotes because that's a actual keyword. Doesn't read right without that. Build your nested quote for loops here to output the multiplication table numbers. Step 7. Here is get the sentinel value from the user, and here's the bottom of the loop. Okay, and it just goes back up there if this is yes, and it repeats everything. So you don't have a ton of work to do, but you do have a little bit of work to do, and you need to test this well before you send it to me because I'll just send it back if it's not doing what I'm asking for. At least I give you the opportunity, right? For now. Let's see, where are we at? Oh, here. Okay, now let's go look at these screenshots. It says here, step 9, your program shall provide output and behave as indicated in the following screenshot. So there's some more information here you need to look at. Now I'll talk about or 2 upper and 2 lower in here. And I've already given it to you anyway. So here's the first one, between 2 and 10. Well, I put in a 1. It says you have an invalid number. It prompts me again. It keeps prompting me until I give it a valid number, and I did. 2 is a valid number from 2 to 10. Please enter the ending number, integer between 2 and 10. 12, you've entered an invalid number, so here I keep going. 1's invalid. Can't be less than the starting number. It's got to be at least equal to the starting number or greater, as I state in the specifications. Now, so that means I always have this column, and I always have that column, and this is dynamic based on what they give me up here. It wouldn't always be 2 to 2, so that's a variable. In this case, if you look up here, my starting number was 2 and my ending number was 2. So that means I've got basically one column and I always have 2 to 10 in the rows. That's always happening there. Now let me show you how this works. For those of you who don't know, and I'm not trying to insult your intelligence, but you may be too young. I have met students who didn't know this. 2 times 2 is 4, right? 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10, all the way down to 10 times 2 is 20. And then you prompt again. So really, this is not that difficult to do. It's just a series of nested for loops. Notice I used a lowercase y, and it accepted that because it cast it to an uppercase. Here's more validation. So now I'm doing from 8 to 10, right? So that gives me 8, 9, 10. That's 1, 2, 3 columns. Now, these are all controlled by the number of what you get from the user, start number, end number, and all that, okay? It's just looping, starting your count at beginning number and going to ending number or less than or equal to, something like that. You can figure it out. It's not going to be that hard for you guys and girls and ladies. 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, and then I can come over here and go 2 times 9 is 18, 2 times 9 is 3 times 9 is 27, and all the way down from 10 times 10 is 100. So you'll need to check yours, make sure you're getting the right output. Remember, I have tabs in there for readability. So let's do another one. Ooh, this one goes all the way from 2 to 10, and you can see how that works. I don't go any further than that because it won't print out or it won't display correctly. It'll wrap and do all kind of crazy stuff. Would you like to generate another table? I said no, and then thanks for using the multiplication table generator. That's pretty much it. This is not that bad. I've done a lot of the work for you. So give it a go. you have a question to ask, I will give you as much help as I possibly can. And don't forget, I have office hours here. Just give me a heads up before you come by if you'd like to come by. I have several students that are doing that. I certainly don't mind helping you. I'll be more than happy to. You just got to give me a heads up to make sure I'm not in a meeting or taking a little time off or whatever. I'm here a lot. So good luck, and I hope you enjoy it. See you later.